All right. Hello, everyone, and welcome to today's Q&A session. We will look at the visualizations of neuromore or our games. We will create a simple neurofeedback application using those visualizations. And last but not least, we will have a look at a more sophisticated example that includes visualizations, the state machine, and of course also the neuromore classifier. So let's get started.
So just out of interest, how many people here is it their first time to one of these? If you guys don't already have your chat open, yeah, you can ask questions as we go along.
All right, so how do you get the neuromore visualizations? How do you get Neuromore Studio? We already covered it in the first Neuromore Q&A session. As a quick reference for everyone who is new to Neuromore and hasn't watched or seen the previous Q&A sessions, they can be found at neuromore.com/tutorials, or you can just go to Neuromore and click on tutorials. All right, so if you already downloaded the Neuromore Studio, most likely you downloaded just a binary of Neuromore Studio. Let me quickly change that. Sorry for that. There we go. So you just go on github.com/neuromore. You select the studio repository, and GitHub slightly changed their layout a bit, so the releases are now on the right side. And starting with a couple of versions ago, there's different binaries available, or different packages. So there's the Neuromore binary for Debian, Ubuntu, the Neuromore DMG binary for macOS. There are the two exe files for Windows, and there's a Neuromore Studio zip, and that contains the Neuromore binary for Windows, and it also contains the visualizations. So if you download that zip file and then you just unpack it, you will find 3 different folders. It's a folder called visualization that contains 4 different visualizations. There's actually 3 different ones. One is Oculus enabled. It's for the DK2. And the other ones are just like simple visualizations that run without any additional VR headsets or things related to that. So if we open up, for me, I have a 64-bit version of Windows running. So I open that Studio version. And what we recently added here, I just close a bunch of the windows that we do not need currently. Under examples, like every user in his personal file system has an examples folder. And at the end, you will find a new folder, visualizations, and there's visualizations test in it. So if you open that up, you see the visualizations test classifier, and that shows what particular feedback values can be fed into the different visualizations. And as you can see, all of those feedback values are just fed in through parameters. Some of them are also created through Signal Generator. So let me make that a little bit smaller. So there's two ways for you to start up the visualizations. One of them is to just start them here through the file system. So each of them are binaries that can be started. An easier way though is down here in the session control in the neuromore studio. If you click on that button, then it just shows you the 4 different visualizations that are available. And if that particular button or the menu visualizations up here is not available, then that simply means that the studio cannot find the visualization, and it looks for the visualizations in its root folder. It's just a file format, or kind of like the folder system that is already contained within the zip file that that you just download. So let's get started with the first visualizations. It's called Cartoon Town. When you open the visualization, it shows that little configuration. You can choose to start it full screen and choose the resolution, or in a windowed mode. You can choose the graphic quality. I just choose fastest for now because I'm running it here in VMware. And I can also select the monitor. The monitor selection is very useful if you have a dual screen system. So you have the studio running on the first screen, and you have a TV or second screen also connected to your computer, and you want to run the visualization just on the second or on the next screen. So for us here to run it all on one screen and have the studio open simultaneously, it's easiest to choose the windowed mode. So if we do that, we open it up. And now the visualization loads up. And as you already can see, now the studio detects the visualization. You can see it that different stages show up in the session control plugin. And now we can just run that particular visualization. And now we see, well, shows we're in the city. There's a car. It's going pretty fast, but it's raining. So using the parameters that we have here in the studio, now we can change particular modalities of that visualization. And not all visualizations support all the different parameters. The parameters that we have in that visualization test classifier represent all the parameters for all the visualizations. So for instance, there's a parameter tunnel alpha. It doesn't work for the Cartoon Town because there is no tunnel. So the primary parameters for the particular Cartoon Town are weather and the speed. And another feature that the visualizations have is the stages that I mentioned. So currently we're in the city, and down here in session control, I could also switch to the farm. Now we're at a farm, and we can, on the farm, control the weather. You know, you can make it a little bit more sunny. You can make it a little bit like more rainy, like here. The rain is also attached to the speed of the windmill. And obviously all those parameters, I'm currently just controlling them using those sliders. But shortly, we will also connect them to other data streams, to real-time data streams. So the Cartoon Town has those two scenes. It's kind of more focused on kids, but I personally think also adults will enjoy it. So that was the Cartoon Town. The next visualization that we have is our infinite tunnel. Same thing, same parameters. We also started up in the windowed mode. Like you can see here, now the studio detected, okay, now we have different stages. We have a stage tunnel, we have a stage spaceship. And let's also get it started. Currently it's like super dark. That's the tunnel alpha that I mentioned. So if you open up the infinite tunnel and you realize, oh, something must be wrong, it looks pretty dark, most likely the tunnel alpha is just it's 0, which means the tunnel is fully transparent. So there is no tunnel. So what we can do here, there's no weather in the tunnel, but we have the alpha of the tunnel. We also have the speed, how fast we're going in the tunnel. Other modalities that we have, we also have it with the cartoon town, by the way. And the other one is that we can add some frost to it and make it, yeah, kind of like icy. It looks pretty pretty icy, and like a training goal for a neurofeedback or biofeedback training session then could be, oh, just remove the ice or make it more icy, less watery. What we also have is we can grayscale it, so we can remove the colors from the tunnel. And what also can be done is a sepia, which is not like a grayscale, is more like a vintage effect that we have here. And what's also available in all of the visualizations that we have is vignetting, which means we just like zoom in the camera here. So it's kind of like that frost, I think, but instead of ice, it will be just blacked out. So in the second stage, in that particular tunnel is spaceship. So if we enable spaceship, now there's the spaceship. It's kind of like the same thing, but it's maybe a little bit nicer because it's not just a tunnel. There's also a spaceship. And with the spaceship, we also have another parameter that we can control. And it's the exhaust smoke of the particular tunnel. What you see in the tunnel, you see it's color changing, and that happens here. It's not a parameter currently, it's just a signal generator. And you see that infinite tunnel has tunnel color A, which is the tunnel alpha that's mapped to the parameter, and then there's a red, a green, and a blue channel that's being fed into the tunnel. Using that signal generator, the tunnel changes its color just automatically. But of course, you could also map the color to a particular parameter. And you can also map that particular feedback node to any kind of real-time biofeedback data, result of a calculation, and so on. But like already mentioned, we will do that shortly.
So just for the audience, mate. So these visualizations are plugins, right? So how are they working?
The visualizations are standalone external applications. They have been built using Unity, and they connect to the studio through OSC. So we can see that pretty easily. Let me.
And I hope
that over.
for those who don't know what OSC is, it's a protocol that you use for very fast communications. And if you see the slashes on the screen, Patrick can probably see how it's got slash exhaust rain slash. So that's very common. So anytime you see something like that, it's also common in web URLs too, but OSC it's used for that too.
Exactly. So all those feedback nodes it's all grayed out because it's currently read only, but I will also show you in a minute how you can make it editable. So, but yeah, all those feedbacks nodes just send OSC messages at a particular OSC address. So those visualizations just consume OSC data and can work with particular OSC addresses. So weather rain, it's just /weather rain. Let me copy it to my personal folder, because currently you can see it's read only because those are examples. They're kind of like templates, and we don't want anyone kind of like to change the templates. But let's assume you wanna change it for yourself. Then a neat feature that applies to all of those examples is that you can right-click on a classifier, and then there's an option copy to personal folder. If I do that, now I have a visualization test underscore a copy in my personal folder. And now it's no longer read only. And yeah, I can change whatever I want. You can change whatever you want, delete notes, add notes. And yeah, I just did that right now because I guess now you can read it better, because the grayed out thing most likely doesn't come out that great on that video conference. So looking at the search visualizations that we have, it's a tropical island. And that tropical island also consumes the weather. So same here. If the tropical island is pretty dark, most likely it's because like the weather is just close to zero, so it's pretty dark. And another aspect that the tropical island can consume is camera movement. So the camera can just go right to left, and you can speed it up a little bit. So the speed then here is attached to the camera movement. Same thing here, we can add that vignette to that particular visualization. We can grayscale the visualization, so asking people to keep it as bright as possible, or keep it as sunny as possible, you know, get rid of the rain. Or super simple, you know, just like make that particular vignette like as big as possible. And the tropical island does not only come with the beach, but it also comes with a ship. And the ship here again, it's just another stage in that particular visualization. It's a little side note, those visualizations currently are only available for Windows. We will work on making them available also for other operating systems. And what's also important to mention, those visualizations have been built using Unity, and we created a Unity prefab. And a Unity prefab is something like a library that you can plug into Unity, into either an existing Unity game or visualizations that you already have, or you can use it to create a new Unity visualization from scratch. And that prefab, once you drag it in, helps you that the connection to the neuromore studio will work out of the box. So you do not have to worry about getting it hooked up, getting OSC set up. Of course, if you want, you can also do it from scratch, but that prefab will get you started pretty quickly. And until we have that prefab available in our open source branch, we are happy to share it with you. And how do you tell us to share it with you? You either write an email to contact@neuromore.com, or you simply use the contact form on Neuromore, like at the end, there's a link, contact. Just fill it out, subject, please send me the prefab, please share it with me, and we will get it into your hands as soon as possible. Like, shouldn't take longer than 2 or 3 days. All right, now we had a brief look at the different visualizations. And I think now it's time to make them independent from the parameters, or at least to make them, you know, to replace some of the parameters with some biodata computation results. So for doing that, let me make the studio a little bit bigger. So yeah, I already shared with you, you're not able to change any of those classifiers in the examples folder. They're read only as it shows up here, but you're able to create as many copies in your personal folder as you want. You do it by right-clicking on the classifier, copy to personal folder. We already did it. Let's do it again. Now we have another copy down here. And let's use, what do we want to change? We want to change sepia, the alpha. I would say, let's say that particular speed node. We do no longer want the speed to be determined by a slider, but now we want the speed to be determined by the amplitude of alpha of a particular EEG gem. So to keep it simple, we use our test device. The test device that we have in the studio and sensors just randomly creates EEG data. And I'll quickly set it up. So we say we care about CZ, we do an FFT, and now we care about a particular frequency band. So we use out of DSP like our frequency band node. We select alpha, it's pre-filled with like 8 to 12 hertz. Like always, if you want to change it, you say, oh, my definition of alpha is slightly different. Change it. You can also type it in if you want to have it more fine-grained. And then we track the statistics node out of our mathematical nodes in here. Say, oh, let's feed that in. Let's say we do mean over like the interval of 1 second. And now there's the mean. So let's look at how the output of that particular statistics node look. And we do that by adding a signal view window. So let's just put it up here. And under output nodes, so we have a view node, and it's pretty simple. Whatever input you connect to that particular view node, it just draws it, you know? And now we see, all right, the alpha mean for our like test feedback system kind of like is between currently 15-ish and 89. And we already saw that the visualizations, like the range of the parameters that need to go into the visualizations need to be between 0 and 1. So how do we get that output remapped to the range between 0 and 1? And the short answer, there's also a node for it. It's our remap node. It's also under the section mathematical nodes. So now we connect that as an input. Just keep that for a second. Let's just replace it, remove that connection. Now we add the output of the remap. Now it still looks the same, but now we say input min 0, input max. Let's say it's 100, and we want to have output minimum between 0 and 1. And to make it sure that it never ever will go above 1, we clamp the output, because otherwise if the input would go above 100, the output would also go above 1. All right, now we achieve that. And we can go ahead and say, well, like here for all visualizations, that movement speed, we disconnect it from the parameter and we connect it to the output of our remap function. And as you can see up here as well, like that signal window will automatically adjust its range within a couple of seconds to match the input. So let's make the studio smaller again. And let's get the infinite tunnel back into the game. And there we go. Now, like the result of our calculation, which was we look at CZ, we do an FFT, we look at our custom alpha frequency band, we look at the mean in the interval of 1 second, we take the output and we remap it to a range between 0 and 1. And now it's being fed into the tunnel and it's being used to control the speed. That's a pretty simple example, but can already be a pretty useful neurofeedback application. And like we already covered it in previous Q&A sessions, of course, you can go as crazy as you want. You can do whatever calculations you want to do. You can connect different channels to different modalities. You can come up with whatever algorithms or formulas that determine the speed. I could also map the delta amplitude to the color. We can get in the spaceship and say, oh, we also want to control the exhaust and so on, you know. So the sky's the limit. You can unleash your creative powers and do whatever you want to do with it. So let me just pause here for a second and let me ask into the round if there's any questions so far in regards to what we just did. And while you guys are potentially typing, up here, for instance, you see a score. That score for itself, of course, is also the result of a particular feedback node. And yeah, doesn't look like we don't have any questions so far. So now let's move on and let's do a little bit more comprehensive example that also includes the state machine. And to do that, I'll just remove that signal view for a second. Just going to focus on the classifier. With today's Q&A session, we also introduced something new. We prepared something for you guys. And that's a particular group folder that's called Q&A sessions, where we will share like some of the examples that we do not want to put into our general examples folder, like the next classifier and state machine that I will show you. And if you want to get access to that particular Q&A sessions folder, same drill, like getting access to the prefab, just go to neuromore.com/contact, fill in your name, email address, subject, please add me to the Q&A sessions folder, and we will also take care of that. So let's look at just do the full screen studio, because first of all, we're going to look at the classifier and the state machine. So that's a 2-channel neurofeedback example. It's way more sophisticated than the ones that we have in the examples folder. It's not super sophisticated. It's also not medically validated, but it touches base on quite some of the functionalities and of the features of the neuromore studio in regards to neurofeedback in particular. So it starts off with the test system here. That particular classifier is currently set up to work with 220 Hertz. So in the input, we resample to 220 Hertz. The classifier, of course, can also be changed to work at a higher sampling rate, lower sampling rate. That's also up to you. The same drill if you want to make modifications to it. Right-click, copy to personal folder. You can change the sensor in the front here. Like for the sake of that demonstration, we use the test system, but you could also use an OpenBCI. You could use the Muse. We recently added support for the Ego devices if you have one of those, and more devices to come. And like already covered in one of the previous sessions as well, if you have a totally different device, you can always stream in OSC data and use that as the real-time biodata input from a studio perspective.
We also have an LSL plugin now, so you can stream to LSL and then forward that onto OSC.
Exactly.
So that's on the README of the project page if you guys are interested in that too.
Yeah. Let's quickly show it. README of the project page means we're here back, github.com/neuromore/studio. If you forget that link for whatever reasons, you can also get there by going on the Neuromore website. You click on download, and if you go and download instructions, you will end up the exact same place. And if you scroll down, you see the LSL to OSC converter that can be used to connect LSL via OSC to the Neuromore Studio. And the same plugin can also be used for Muse 2. With Muse 2, we also have another plugin that has been created that involves a Python script, I guess, to do the same. So the classifier starts with resampling. Resampling, for instance, is not necessary if your input stream is already 220. If not, you just use that particular resample node. If you wonder where the resample node is located, it's under utils resample, and you just determine what's the target sampling rate. Here's 220, and it takes care of it. We have a particular section of cloud parameters here. We briefly mentioned the cloud parameters also in the introduction to Neuromore and the first Q&A sessions. That's cloud parameters in action, like here in the classifier. We will not go into detail for today. If you guys wish, we can cover the cloud parameters in one of the upcoming Q&A sessions. Then what happens up here, we have a session info node that's being used to calculate the elapsed time. It's being used to calculate how much time has been spent within the neurofeedback session, and you will see the difference shortly. We calculate the play session half time because it's a little hint. We will look at the state machine shortly, but it plays different audio snippets, different vocal commands, and it also uses the information if the session is already halfway done. Then we have a sample gate around here. It's a pretty basic epoch filter, you know, to see, oh, is the data any good? Is it not any good? And we won't let it through. We detect if the BCI is online. It's currently just hacked here. We can as well also connect that particular node to an online switch. Some of the devices have the information. Well, am I ready? Am I connected? Am I in the right state? For instance, being in the right state might be some amplifiers can be in an impedance test mode and can be in a data collection mode. The Muse, for instance, Muse SDK outputs, am I okay or not? So we just set it to 1 to make it more compatible. So it works with the test system and it works with all the amplifiers that do not explicitly provide that particular information. Then we have a little baseline capture in here. So we're taking 1,000 valid epochs to determine a baseline. That particular classifier takes a theta baseline, alpha baseline, a beta baseline, a high beta baseline. Thresholds are being updated. Up here, we have the protocol. Currently, it's set in that configuration to inhibit certain channels. So like I already mentioned, that's not medically validated. It's just something that we created for demonstration purposes. But if you're an experienced neurofeedback practitioner, or if you're just an enthusiast and you know how your protocol should look like, that's kind of like the area where you want to look at to inhibit the channels that you want to inhibit, to augment the channels that you want to augment. And down here, you can determine what kind of baseline you want to take. And all that then feeds into particular outputs that are being calculated. So that particular classifier, on the one hand, takes care of volume. So it's capable of controlling the volume that comes out of the studio to give real-time feedback. There's also a bunch of parameters that are available: override volume, minimum volume, maximum volume, and so on. So if interested, please ask. If not, you can just play around with it. And then there's a score that's being calculated. So score is kind of like, how good is someone currently doing? Then we have a bunch of outputs here. So we have a volume node out here. So that particular volume node is pretty interesting, because if you call the volume node just volume, like it's spelled here, like with a starting with a capital, and then lowercase, then the studio automatically uses that particular node to control the output of an experience of the studio in real time. What we did down here, we just added some OC feedback. So that particular feedback node it just transmits on OC address /feedback/1. It also transmit /feedback/0. We output the speed, and as you can see here, that's like /movement speed. So that tells the particular visualization, hey, I'm telling you visualizations what the speed will be. And down here, you can see it's like the generic neurofeedback tunnel experience. So it has been custom tailored for our infinite tunnel. So it also tells the tunnel it's some alpha channel. It's just a hard-coded one here. And you can see that the signal generator feeds into a color wheel. And that just creates kind of like alternating colors and feeds into the visualization, the red, green, and the blue value. And down here, we have some points. Those points are being saved to the classifier. That's a cloud upload node. We have some total points, rating, mean score. So the overall intention with that classifier is just to touch base on different aspects that are related to neurofeedback. And it's not really meant to be a template for production neurofeedback sessions. We also have different templates for that. So if you're interested in that, please also reach out. The overall intention here is just to showcase different aspects and give you a playground, so you don't have to figure out how different things can work with each other, how nodes can be connected, and so on. So that's the neurofeedback classifier, or generic neurofeedback classifier. And then we also have a matching state machine to it. To look at the state machine, first of all, let me just close the classifier. So what we have here, state machine. The previous Q&A session was all about state machines, about what the states are, how to use it, how to set it up. So if you're new to the state machine, we highly recommend you to check out the Q&A session about state machines. And that's kind of like a state machine that we created. So what it does, it sets particular parameters within the classifier. Then it asks the user how much time the user has. It does some initial checks in here. determines, is the signal any good? Oh, signal is perfect, it's acceptable, and so on. Then, and in case of the signal is bad, then it shows some recommendations, kind of like, oh, maybe you put on the amplifier the wrong way, or maybe you just need to relax a little bit more, relax your head muscles. If it's still bad, it shows, oh, maybe there's some hairs in between, like your head or your skin and the sensor. And last but not least, maybe you also need to just adjust the band, adjust the sensor, and so on. So those are some of the troubleshooting advices that we came across that really help the average user to get it up and running. Of course, feel free to change whatever you want. In here, in those notes, you can see it's just pictures, just JPEGs, you know, that are being displayed. So you can make it as, let's say, cheap as just replacing the image URL, pointing to another publicly available address. You can change the node. Might also want to add a video or whatever. So once the signal quality is acceptable, we say, oh, well, it's all looking good, you know, we're getting like good signal. We move on. And then we play an intro. And the intention of the intro here really is to educate the user. It's mostly aimed on people who do the session the first time. So let's consider you want to create a simple, consumer-friendly, push-button easy application. So people just press the play button. We made sure that the signal quality is okay. If not, we gave them some advice to hopefully fix it. Now we got to a place that it's being set up correctly. And now we play an intro to tell the people what's about to happen, what the whole experience is about, and so on. People are also able to skip that particular intro. Then we begin, we play a little background music, and we play a little background video within the studio. And no worries, we will look at all that in action. I just want to walk you through kind of like how everything works that we're about to look at. Then the baseline is being captured, you know, then we're back, you know, it's like during baseline capturing, signal drops, then we give some advice, we show the progress of the baseline, and then here the neurofeedback session begins. That's kind of like where the training begins. And while the training is running, now the classifier is fully active, so now the visualization shows or kind of like gives feedback, like in that particular case, through the speed in the tunnel and through the volume of the voice, through the volume of the background music. And additionally, we also have that section up here. And what it does, it every 20 to 30 seconds, it looks at how well is the user currently doing. And we have two possibilities. Either the user is doing pretty well, and then we randomly play like one of those reward audio clips. And you will hear them. Oh, you're doing good. Yeah, continue like that. You're getting more and more focused and so on. Or if we realize, looks like during the session, the user is really struggling, then we play some advice. And same story here, all those clips are nothing more than just like MP3 files that sit on the neuromore cloud. You can do your own recordings, just upload them somewhere accessible, change the URL in those particular action states, and then you have your custom reward clips, your custom advice, you know, because we also seen a lot of people who use just that particular section to also add a whole psychological aspect to the whole experience. And that's something very interesting, and I personally believe also very unique, because that gives you the ability to go beyond traditional neurofeedback and biofeedback and also add the psychological component to it. So what we've seen a lot is that in traditional setups, there is a neurofeedback practitioner. He or she hooks up his client and then sits right next to the client and gives advice and some recommendation or some rewards just personally, like in person. But that particular setup really enables you to create fully unsupervised neurofeedback applications that still represent your style of doing sessions, your particular psychological style, NLP style, like whatever it be, you know, it's like it's a fully generic approach to enable you with kind of like household tools. And the household tools here is just like you need to be able to record an MP3 file and upload it and create a fully interactive audio visual neurofeedback or biofeedback session that also has a psychological component to it. So lots of talk. Let's look at it. So let's also put on like a little bit more the end user's head. Let's do it somehow in between, you know, let's add a little signal view to it.
And so just to give some background too, is this system has been used for, you know, football teams, for focus training. It's been used for veterans and who are kind of recovering from trauma. Patrick, do you want to go into a couple more things that or ideas that people might be able to think of ways in which to use it?
Well, absolutely. So let me like do one step back and let's mention that those particular neurofeedback application or that particular example actually runs in the neuromore application where people do only see that experience window. So if you create a particular application, then we do not see a backend file system, the signal view, the session control. So that's already kind of like less nerdy than looking at the classifier and the state machine, but it's still kind of like the professional perspective at it. But all the things that we just looked at can be already played using the neuromore iOS and Android application. And those applications are also available for you to be licensed to create your own custom white labeled application using that. And let's circle back to your initial question, Andy. So those iOS and Android applications have been used for focus training. They have been used for relaxation training. They also have been used in combination with heart rate sensors and heart rate variability sensors to create a breathing pacer, for instance, kind of like to help people to get into the right breathing, to make kind of like that switch between the sympathetic and parasympathetic nervous system to help people really to relax. We've seen other applications that also run on iOS and Android that additionally use the galvanic skin response sensor, kind of like skin resistance, for similar use cases, kind of like helping people to stay calm, you know, in particular situations. We have seen iOS applications, Android applications, as well as the more professional application using the neuromore Studio. And one of the visualizations, like I already mentioned, the usual setup for those professionals is that they have two screens, or they have a laptop and one external screen, or have a laptop and connected to a TV, that they look on their machine, on their screen at the neuromore Studio, and their client looks just at the visualizations, and there's some nice speakers. And that particular setup has been used like full spectrum, from helping truck addicts to get off trucks, to help people to get more resilient, to do ADHD training, to help people to focus better. We have been working with a company that does test preparation, kind of like SAT and all those like standardized testings. And they have seen great results using traditional ADHD protocols, also in kids who are not diagnosed with ADHD, but they have been able to significantly like improve their test scores. Then there's another realm, you know, that we already kind of like touched base on using HRV, but also using neurofeedback and other modalities, which is yeah, massively growing issues like all over is depression, burnout prevention, kind of like helping people to mentally relax, and the mental relaxation. It's mostly in the realm of the brain, of EEG, but on the other hand, also to physically or kind of like more physiologically relax. And we've seen that happens more using HRV. The beautiful thing is here, and we have been working with some people who did setups for offices, kind of like huge offices, and they set up a bunch of kind of like it. There's a huge variation how they called it, how they framed it. Some called it timeout room, other called it like the meditation booth and so on. But it was all the same. It was kind of like people could hook themselves up during their work hours, and their employers really incentivize that, because they realize that it's highly beneficial for employees if they are kind of like in a good mental state, in a relaxed mental state. Yeah, and I guess I could go on forever, but
Yeah, I think one more, mate, is probably neuromarketing too. I think that that's
absolutely,
yeah,
absolutely.
But I think the world's your oyster, everyone. So if you do want to add new ideas, we'll definitely support you.
Yeah, absolutely. So let's make sure it's loaded. All right. So now we start the session. We press the play button, and the tunnel is being initialized. And now, how much time do you have? And let's just say we have 5 minutes. You see the buttons down here. So everything that we see now within the experience, everything that happens, like all of its source code sits within the classifier in the state machine. So there's not a single line of custom code within the studios, somewhere like that. Now we say, 5 minutes. Now we're checking the signal. Like I already showed you, we always have good signal if we do like demos. And now we have the introduction. And let me turn up my speaker a little bit, so hopefully you can hear that.
So that you can achieve mental flexibility and focused attention. You can learn how to reduce brain activity associated with low performance and increase brain activity.
I'll spare you the full focus intro, which takes a couple of minutes. You know, if you can just get access to the Q&A sessions folders, and you can play it as often as you want. All right, and now you're in control. And now we have a background sound, and the experience is going. Now I float in the tunnel, and the only task that I have is go as fast as you can in the tunnel and keep the volume as loud as possible. And some people said, well, maybe if we do relaxation, maybe I want to go as slow as possible. It's pretty easy. We already showed you earlier how you can mess around with the data that's being fed to the visualization. And I don't know if you hear the audio cues. Maybe what I do a little tweak to, let me just remove the background sound. So we can just listen to the audio cues. And Sorry for that. In one of the next Q&A sessions, I find a better way to redirect the audio output of the studio into Zoom without like using my headset and the speaker of my laptop. So that's where the background music is being started. And what we do, we just disconnect it. All right. No more background. So reload it. Takes a few seconds to run through all the checks. Now there's the focus introduction. As we skip the introduction, now you see that behind the focus introduction, we were recording a baseline. Again here, most likely that's not medically valid, you know, that you record a baseline while you expose people to an introduction or through some audio. For demonstration cases, it works out perfectly. So. Right, we're getting close to the 1,000 valid epochs, and we have the 1,000 valid epochs. Now we're going in the tunnel. And as we've seen in the state machine, now every 20 to 30 seconds, there's an audio cue based on the score. Let's just pull up my speaker. I'll wait for that.
Continue as you are now. You are becoming more and more focused.
Yeah, and we have those audio cues, right? So you can play them more frequently, less frequently. It sounds better if there's some background music, but just to showcase it more clearly.
And to debug, I think you can, just in case anybody missed the state machine tutorial, you can actually see the basically the signals inside the state machine signal and transition from state to state.
Oh, good point, Andy. Well, I'm just gonna show that because I think it also looks nice.
There is nothing for you to do or not do.
All right.
Just continue to keep your attention on.
Let us move that experience window over here. Let's move that down here. And you might have also already realized that you can mess around with the windows in the studio. Sometimes something like which just happened to me, that it looks weird happen, but then you just rearrange it, make it how you want to have it look like. And there's also a little trick, by the way, for you guys. If for whatever reason the state machine looks black, that just means that the focus is not right in the middle, and you can focus right into the state machine, and you can focus right into the middle of the classifier by pressing the A key on your keyboard. And then it's back. So it's kind of like easy to be somewhere out, you know, and then like, oh, where's the state machine? And just press A and it will be back. So yeah, what Andy just mentioned, like here, now the whole thing is active. So we see that we're currently here. And let's replay the whole thing. Let's do that. Let's reload it. Bam. Here we are, session control started. All right, now we're here in that state. And select duration, 5, 10, 20 minutes. And if I click 5, we can see, bam, now start checking signal. Now you see we're currently stuck in that acceptable state. Now it's okay. Focus introduction, play intro. If I skip intro, I go along here. Now you see wait for baseline, update the display, and update the display. It just like writes that new like information up into that experience window. baseline, bum, bum, bum. And the condition to move on to start neurofeedback is that the baseline is complete. And it happens now. Now we're here. Now there's also something interesting. You can see that the state machine can have multiple states being active simultaneously, certain triggers and so on. And that also massively helps you to debug, see what's going on, and to make the changes that you want to see. All right, there's a question for Marco. So he's asking, you have implemented a new way in using videos and audios for the feedback, how to use them. It's pretty simple if we do not use the visualizations, if we only rely. Let me stop there. So, if you use audio, like the overall volume of the studio is being controlled, and the whole feedback control happens through the classifier. So let's get it back up. Classifier. So the result of the feedback node volume will control the volume of the audio of the studio. And for video, we also have 2 feedback nodes, I believe, but I don't know it by heart. We'll add it later on. That I believe is called video alpha and video grayscale. And you can use those 2 feedback nodes to control the video that's being played in that particular experience window. That being said, it's also important to mention that you do not need those visualizations that we just showed you to have a full-blown neurofeedback experience. Of course, you can also just use audio, and you can play videos within that experience window, and then control currently, it's the alpha channel and the color saturation that we offer. And yeah, we will also document that more clearly, because currently you have to watch that Q&A session. You have to know it's the node name volume, and I believe video alpha and video saturation. But we will add that later on. Great question. Do we have any other questions for today? All right, then let me ask another question. What topics would you like to see covered in the next and upcoming Q&A sessions? And like always, we will leave the chat open for a few more minutes. So you don't have to rush. You can just type it in if you want. Otherwise, we also have some beautiful ideas and some beautiful examples that we will cover anytime soon. Andy, anything else from your end?
Yeah, I was just going to say, guys, if you do want to suggest anything, I think maybe one of the best ways is either through the website, the neuromore.com, or you can also find us at the GitHub, like the Neuromore Studio GitHub, which I've just added to the chat link. We will be posting the videos that we've presented today. So if there's anything that you forgot or you missed, please go to YouTube, or you can find the links through our site.
Yeah.
But yeah, please stay in touch, and we look forward to seeing you at the next one.
Thanks, guys. Take care.
Thanks, guys.